All right, why did you guys have to say such mean things about Michelle and Gian and Prime and Rogue? That wasn't very nice. All right, cool. So, last little piece here. We have looked all chapter at rigid motions. Give me three of them. Translation, reflection, rotation. We have those three, right? And then we've just been looking at how do they work independently, how do they work if we put multiple of them together, so forth and so on. For today, we are in the last section, and this is 3.5, and we're going to be talking a little bit more about symmetry. Now, I'm going to sneak this in as a definition right in the top, and we don't even have a main bullet point today because all of our focus is around two different types of symmetry. So right off the bat, what does it mean if something is symmetric? The same. So I'm going to put a couple graphs up here, and I think I have one already ready. It's not that. It's here. Does this thing right here have symmetry? Yes. Now, when I say it has symmetry, you're probably viewing it a couple different ways, realistically. Now, what do you mean by symmetry? Because I think I agree that there is symmetry, but what is it that you're referring to? Like, how could you convince me? Every portion is the same. So if I wanted to draw something to like really accentuate the symmetry, what would you have me draw on this? Okay, we can draw a line through it, right? So that's weird because if you actually count it, I'm pretty sure there's an odd number, but I think I agree with you. You do not have to draw this, and I would encourage you not to. If you have a spirograph at home, anybody have the little things with the gears that you spin? They're awesome. If you've never played with one, they sell them at Safeway. They're hanging up in a random aisle. They're like $5. It's the best $5 you'll ever spend if you like cool designs. Okay, now with this, again, you do not have to draw it, but I think that I agree with you. There exist lines on this thing somewhere, like maybe this is one of them, and this is why I was saying about the points aren't really the same, and I'll try one more. If I drew this line, and I just reflected it over, would this point reflect to here? And this point to here? And this point to here, like they all land on itself. Can we all agree that if we just folded it over, every point lands on its counterpart? Okay, we just did a reflection to get there, and we happen to draw a line. Is that the only line that I could draw? No, I could draw another one right here, and really anywhere that I put it, as long as it maps on both sides, there's a bunch of them. I think there's like 17 or 18 on this figure. I didn't really count. Is that the only kind of symmetry that we could get? Reflecting. How else could I make this thing land on itself? I might have just given it away on accident. We could rotate it. Now, I don't have the capability to truly rotate it, but check it out. I'm going to let my fingertips just represent these intersections. I'm just going to rotate about my thumb. There is an amount of rotation that if I go this far, did they both land on that same point elsewhere? So what I see is the figure is landing on itself. I could spin it 180 degrees and it would probably land on itself. Whether or not 180 actually works, I'd have to count them to see. But there are rotations that I could get it each time to just, it look like the same picture, right? Now, what we've just identified is two different types of symmetry. But before we get there, let's all agree. If I spin it about this point, or if I reflect it over this line, it would land back on itself, right? Now, land on itself isn't the formal language that we use. When I have you do this notation, A something A prime, what is that notation called? Map. So, as a quick and easy way to define these, landing on itself is fine, but it's not very formal. We can define symmetry as any rigid motion, and any rigid motion that maps a figure onto itself. Now, for these, maps a figure onto itself. It could be a reflection, it could be a rotation. A translation will not do it because by translating, you're physically moving it and it's not going to land back on itself anytime. Okay, I use the language mapping. That's a much more formal. Are we okay with that's the same idea as landing on it? Okay, that's a wrong way to ask that question, but I'll take it. Now, there are only two flavors, and I know that that's a weird thing to use, but it's what in my head that makes sense. Only two types of symmetry that we're really worried about and that we're going to deal with, at least in this section. The first of these is called reflectional. Reflectional. And I don't love this. That word just feels off to me. I prefer to call this line symmetry, but it's truly reflectional because you are reflecting across a line. Okay, reflectional symmetry. And what was the other one that we looked at with that big ugly figure? Rotational. Okay, rotational. As we look at this, I'm going to define it, but I would encourage you to use your own judgment as to whether you write this down. If symmetry just means a figure maps to itself, if it's reflectional, it maps to itself with a what? Good. With reflection. Again, use your judgment as to whether you think you need to write this down. If we know that symmetry just means it maps to itself, if it's reflectional, it reflects onto itself. What do you think we might be able to say about rotational? Rotates onto what? Itself. Okay, that is it. All figures, I think, probably have at least a really boring kind of rotational symmetry. And we'll look at that here in a second. Are we okay with just a definition of these? Okay, here's the cool part. For these next few, and you're going to have time for a homework assignment today, but we don't have to get real crazy with this. I'm going to put some pictures up here. And do you guys know the shorthand for pasting a picture or pasting something on your computer? Control V will do it. Control C copies. Control X cuts. Accidentally today, I hit Windows V, and check this out. It pulls up everything that I've done recently, which is incredibly convenient for me, probably less for you, but if you're going to use it. Okay, for the following, you don't even have to write this down, but as long as you're engaged and paying attention, we are fine. I'm going to throw up a few pictures here, and I just want your help determining, does this picture right here have symmetry? Now, I clipped it a little bit too far. You guys say yes, maybe. I'm not convinced yet. When I say, does it have symmetry? If you say yes, I'm okay with it. We'll see if you're right, but we need to be more specific. When you say yes, is it with reflectional or is it with rotational? Rotational? Is there reflectional symmetry on this? No. Okay, so somebody's going to be tempted to say yes. Now, if it was just a square, it would, right? Now, if we actually took this figure, though, and with all the details in it, if I drew the line where I would want the line of reflection, it'd be here, right? But here's the issue. If I reflect this over, it comes to right here. If I reflect this little segment, it comes here, and then it would do something like this, right? Does it match? So does it have reflectional symmetry there? No. Like, it looks like it should, and the shape does, but the image itself doesn't. Does it have reflectional symmetry right there? No, because I can tell very clearly this pointy part of the arrow will not fold up onto a pointy part of the arrow. Even though it looks like it does, if you pay a little bit careful attention and look at it, you'll see that it really doesn't. Okay. Do we conclude then that it doesn't have any symmetry? So I don't know that I agree with you. I think it does. And this is going to be the weirdest thing, but I'm actually going to use Word for this one. Okay. So looking at this, only reason I'm using Word is because I can do this on here. I'm going to post that picture. Here it is. And I'm just going to copy this and post it again. If we just rotate it, here's 90 degrees. Does that look the exact same as where we started? Here's 180. Does that look the same as where we started? For sure. So I can see very clearly that this thing does have some symmetry. It only had rotational symmetry. What was the degree, we can say, that I had to rotate to get it to be there? 180. Okay. Does that seem okay? Should we try? Let's try a couple more. I'm going to go back over to this screen. We already looked at that big figure. I'm cool with that. I'm going to see if we have some other ones. Ooh, I like this one. From this, talk with your neighbors, your group, for like 60 seconds. And I want you guys to help me determine, does this one have reflectional or rotational symmetry? If it does have reflectional, how many lines of symmetry do you think it has? If it has rotational, what are the possible number of degrees? I'm going to give you guys like 60 seconds. We'll come back together, chat with your neighbors. Now, this image right here, does it have line or reflection symmetry? Okay, so line is reflection. They're the same thing. Does everybody agree this thing has reflection symmetry? How many lines of reflection? Interesting. Interesting. So, did a lot of people just change? It should still be 2. Now, a lot of people see 4 initially, and we're going to see why not. This one, I think, is fine. I can see this maps to this. Cool. That one's fine, and it's going to happen with all of them. This one, also fine. And I'm eyeballing it, right? But also fine. I could fold it, and it would land on itself. Somebody is going to be tempted to say this one as well. Now, somebody, and I agree that it's no, but if you're not sure of that or you don't understand why, I'm just going to do the same thing that we do when we reflect. Let's say I reflected this point. It goes perpendicular to the line, right? Do you guys agree that that is about perpendicular? Like even maybe down here. Like that looks about like a right angle on my screen. Sevia, do you agree? Good. Cool. Now, you guys help me eyeball it. Here's this distance. Where's that distance here? Is it about there still? Did that land on itself? No. Why doesn't this one have that line of symmetry? If we had the side lengths all the same, we would be okay. It's a little bit elongated though, right? This is not a regular polygon is the way that we would say that, but it does not map onto itself. If you struggle to see these, what magical thing have we been using throughout the last few sections that might help? Protractor might help. It probably would if you want to do it. Is there an easier thing? Tracing paper. Holy cow, the tracing paper. Okay, what about rotational?
Yes, 180.
180 degrees. I assume that my center is here. If I only go 90, my shape, yeah, it winds up looking like this, and we'd have points over here, and it wouldn't quite work. Something like that. I'm not spending a whole lot of time drawing it, but 90 wouldn't work. Would 180 work? Yes. Okay. One more going through here. I just want to look at a couple more. When we look at rotational in our notes, and there's only going to be like these little bit of notes today, not much more to write down. Compared with rotational, just like we can say line symmetry, pretty common that we'll refer to this as point symmetry. If we rotate about a point, we can call it our lovely point symmetry. Okay, let's take a look at a few more on your homework. I would strongly encourage tracing paper. Okay, looking at just a couple more real quick together. Let's look at this one. Does it have reflection symmetry? No. Now, no matter where we try to draw it, I see that these aren't the same on each side, so this would reflect and be pointing up like this on the way down. It just won't work. Does it have rotational symmetry? Yes. How many different degrees could we rotate through that would land on itself? 120? How did you get that so quickly? Divide by 3. There's 3 pieces that are identical. They're just rotations of one another. If I went 120 degrees, this one would rotate. I'm just going to look at that. That's a flat side. It would rotate about, and it sits on the flat part. It does work. It's hard to envision these things, and I get that. Tracing paper, for real.
The bottom left one is different from the other two. The way it's like looks like it's folded.
Oh, this fold. Do you guys see it coming over the top or under? This one? Doesn't this one look like it comes like this and comes like this over top to you? Is it? I think this one goes behind itself. I think this one goes. We'll check. Like, I saw it at first, but I think Elijah's right. I need this. I'm going to look real quick, and we'll just actually take it. We'll see. Okay, so looking at this, and again, will the tracing paper help? For sure. But what Elijah's saying, and we'll all see it, I imagine, once I post this. Great catch there, Elijah. Okay. Lost my spot. Here it is. So I thought so as well, but let's check. I'm going to post this twice. And the question is, are these really all the same? And it's hard to envision sometimes. I'm going to rotate until that one's flat on top, so about like that, right? Nope, that's way off. So there's our original. Where are you going? Get out of here. All right. Here we go. We'll go here first, and then we'll go counterclockwise. If I put it like this, Ooh, are they the same?
No, they're not. No.
The arrows are
Notice that this one, we see the front of it, and then we see the back end. This one, we see the back end, and now we see the front. Great catch, Elijah. Okay, looking at this. If you don't see what I'm saying, let me check first. Anybody not quite see what we just discussed? Everybody can see it? Okay, well, I won't go into it further then. Okay,
So
look.
if it didn't have the lines on
If it didn't have the weird little flop, yes, it would work. Now, when I'm looking at these, the type of questions that I would do would be easier, only because, one, I don't like the idea of like maybe a trick, because it certainly looks like it should, right? And it got me good too. But as we look at this, this figure is much more in line with what I would give you. Does this one have line symmetry?
Yes.
How many lines? Two?
Four.
One here, one here, one here, and one here. There's four. Is there point symmetry? Okay, what's
No.
you?
Yes.
I think if I spin around this point, 90 works.
No,
180 would work.
it looks bigger on the side.
I don't think it is. I think it just might be your perspective. Okay. Now, as we look through these, you're going to inevitably encounter some of the weird ones where you go yes and then immediately change once you look at it a little bit further. That's okay. This thing or this topic gets hit a heck of a lot less in this book than I've ever dealt with. Now, if I wanted to find the amount of rotation, like for example, this figure has point symmetry. What's the smallest rotation that it lands on itself? How on earth did you get that? There's four of them, and you know that a full circle is 360. So if you realize how many times it lands on itself, you just do the division, right? Okay. Other weird ones, and this is, I don't love it, and I'm not going to give you either of these problems. Does this one have point symmetry? Are you sure?
No.
Okay. What is point symmetry?
No.
So give me another word for point symmetry real quick. Rotation. It will. It looks like it shouldn't, but notice this. Do you guys agree this is an up? When I flip it over, it becomes a down, which is a weird idea. Tracing paper. I just want to stress. Use it. Okay. How about this one? Does this have point symmetry?
No.
So there's a question. If I say what's a common factor between two numbers and you give me one, is it really meaningful? No. Any figure that you were to pin down and spin 360 degrees, what's it going to do? It's going to land on itself. Let's just all agree we'll say no if that's the only one. If it has rotational symmetry but it's 360 degrees is the smallest, we'll just say no. It doesn't really have any because otherwise every single thing would have to be a yes. Okay. If it's only 360, what are we going to say? No. Cool. All right. That's all I got. I want us to try that or try the assignment. For the assignment, which I will give you guys right now, I'll be passing back the quizzes in just a moment. I believe all the grades are in the grade book, but let me go here. Where am I trying to go? The internet. There we go. Here. All right. This evening, or this weekend rather, we just did 3.5, which is symmetry, and you guys get the privilege of homework 3.5, which will be on page 142. I want you guys to do 12, 13, 18 through 24, and 27. Okay, just to make sure, in case or when somebody comes in on Monday and they say, I didn't know we had a quiz, check it out. Monday will be the 27th. We are going to do practice test. Thank you. In class on the 27th. That's next Monday. On Tuesday, what do we say we're going to do? The Chapter 3 test. We'll call it version 1. On that Wednesday, on Wednesday, we'll have to kind of play it by ear. Right now, my immediate thought is if the test goes poorly, which it won't because, again, we're taking it next Tuesday. Everybody knows about it. I can give you note cards if you want to work on them over the weekend. I'm cool with that. But if it goes poorly, that extra Wednesday, I don't intend to start a new chapter. I can't. Cool. All right. We have 7 minutes is all. I'm going to pass back the quizzes real quick. If you want to start the assignment, you can. We'll probably look at the quiz key really briefly. Ooh. Yes. I really take your book and your notes. Okay. Yep. I'm going to make anybody who doesn't get a quiz back right now, I'm going to make you step out for just a moment. You can take your book with you. Yep. I'm going to kick you out for a second.